So we're from LT Grasso Technical High School. It's a tech school in Southeastern Connecticut, as she said earlier, where you can choose a trade to study. Our chosen trade is Bioscience and Environmental Technology, which is what led us to our project here.
Can you tell me a little bit more about your project?
We had come across compost as a common everyday object, and this everyday object produces heat, and that heat just goes off into the atmosphere. And so our problem was we wanted to figure out how to use that heat. And so we were thinking, what do we use heat for every day? We use heat to heat our homes. So how can we get this heat out of the compost? We can run copper piping through a pile of compost, and so this unit will hold compost, and the copper piping will take the heat out of the compost and transfer it into water. And that water can be sent into the return line for your boiler, and that, instead of water being 50 degrees going into your boiler, it's now going to be 90 degrees. And so your water boiler doesn't have to kick on for that extra 20 minutes to heat the water another 40 degrees, saving energy.
That sounds really cool. What kind of challenges did you run into while you guys did this?
We had many challenges, like the technical with the thermometers and stuff. Do you want to talk about those?
Absolutely. So one of the things we've learned about invention through the process is it's about 90% failure and 10% success. Now, we've run into quite a few challenges, some design related, some technical challenges, and then some just we didn't have the right idea at the right time.
Like using the actual composter. One thing, we started off, if you come and look over here, one thing is we originally cut the whole door off, and that damaged structural integrity. So now we've gone from cutting that whole door off to having a section on the top and bottom, and that section is now holding up the integrity, and when we shut it, it stays shut now, because before it was mislining up and stuff, and so we had to overcome that lining of it and figure out how to fix it. So that was a pretty big challenge for us. And then we also had ease of use challenges. The ease of use.
That's right. So our first prototype was mostly just a proof of concept. What we had was, it looked almost identical to this. It was just a 55-gallon drum. We hadn't yet put any copper piping through it, and we didn't yet have a door. What we did was we just filled it with compost, put a thermometer in, and had a thermometer out here, and measured it. And then it came time to empty it.
So cleaning that out was awful.
Now, one of these full of compost weighs about 300 pounds, so you'd have to take this, tip it over onto your floor, get on your knees, and pull it all out by hand with a hoe, and it was a dirty, nasty job.
So now by adding this door to it, you open it up, and it pops out. And if you come over here again to our photos, we have a picture of it right here. So now you can just pull it out, and it all comes out straight into your garden, and it's much easier to handle. And then also we started with a coil inside it. And that coil, though it's a good design and used often, it wasn't very structurally sound. So we moved to using the more rigid up and down from the top to the bottom. So that way when you pull the compost out, it doesn't get caught in the coil, and it stays in and isn't damaged by actually using the product.
Cool. So now I want you guys to describe EurekaFest in one word for me.
It's just huge. Everything going on. Everything. It's such a big lead up after 2 years of working on this.
What about you?
The word inspiring comes to mind. Being around so many incredibly intelligent people in one place. Normally, this kind of brain power is just, you don't come across it every day. But here at MIT, almost everybody I run into is not only intelligent, but accomplished, and they are using every bit of their potential to try and better the world.
Awesome. Thank you guys so much.
Thank you.